Okay, so last week we were opportune to see Docker file, what a Docker file is, right? Prior to then, a week before then, we have been working with customized uh, ready-made images, right? Ready-made images on from Docker Hub, working with MySQL, Apache, Ubuntu, CentOS, and the likes. And last week was an opportunity for us to see how these images are being created, right? And how these images are being created through the concept of Dockerfile. So Dockerfile, as we are told, is a technique that is used to create customizable images, all right? To create images, your own image, right? And use it the way you want to use it. So we saw all of that. We saw different Dockerfile instructions, okay? How to use instructions in Dockerfile. Then, yeah. So we didn't see one last item on that list, which is multi-stage build. All right, it's multi-stage build. Multi-stage build in Dockerfile or in Docker is very important. It's very key. All right, it's very key. Most of the interviews you attend, and if you are drilled on Docker, they cannot miss asking you what do you understand by a multi-stage build. All right, the question will come in different ways. How do you reduce the size of an image? Right, before I come to that, let's get started. So multi-stage build. All right, so multi-stage build in Docker. So this concept, all right, I would say this concept idea, same. All right, this method is used to reduce the size of a Docker image. So that is your answer, guy. All right. You will be asked, what do you understand by multi-stage in Docker? So multi-stage in Docker is a concept that is used to reduce the size of an image. We're going to explain how to implement multi-stage. Before we implement multi-stage, we are going to look at an illustration, right? We're going to illustrate multi-stage. Then we're going to use the concepts of that multi-stage to build a real-world image, a real-time, right? A real-world image. So the idea is to reduce the size of a Docker image. It's either ways. You could be asked. You could be asked like this. What is, or what do you understand by Docker multi-stage build? Or how do you reduce the size of a Docker image? How to reduce the size of a Docker image is with the use of multi-stage build. Bam. That's a number one very basic response. However, if the interviewer is technically sound, the interviewer will now ask you another question. Okay, if you say so, what if I build my image with Alpine? Alpine. What if I build my image on Alpine. So it is understood that Alpine are lightweight images. Alpine are lightweight Docker images. So now every image has an Alpine version, be it Ubuntu, be it Nginx, be it Apache, be it MySQL. They all have Alpine version. Let's check something now. So if I go to Docker hub.docker.com, or even without going to Docker Hub, let me just go to Google. Now I'll say Docker MySQL. I'll go to the official image of MySQL. Now, if now I now go to tags, let's go to tags. Tags, we're going to see different kinds of tags. Tags with Alpine. I should see a tag. Can I search? I can search. So let me say Alpine. What was this now? A to Z. Aba. Z to A. Oldest. Why am I not seeing Alpine? I should see Alpine. I should see Alpine. 1 second. What I'm seeing is Debian. All right, let me search. Docker, MySQL, Alpine. Upon MySQL, I need official image. I need official image, not any image. Overview. Let me check this overview. Well, I don't know if you see Alpine. I used to not get Alpine. Let me check. Let me check Open JDK. Open JDK. Official. Alpine. Search Alpine. Including Alpine Linux. Just wait. Let me check something. Tags. Okay. So OpenJDK has Alpine version, right? Alpine tag. So 19 JDK, this is latest version of Java, right? Java 19. So let me look at A to Z. From Java 12, I should have from Java 8. Oldest. Let's look for oldest. Java 7. So you can see it has Alpine version, right? So these Alpines, they are very small images. Very small images. Let me also check for let's check for Ubuntu. Official Docker image. Let's go to tag. Let's search for Alpine. All right, doesn't have. Ubuntu doesn't have, right? So have it at the back of your mind, at the back of your head, that Alpine is a lightweight image. So now the interviewer will ask you, so what if I build with Alpine? Alpine is smaller. All right. Now, this is what you tell them. You tell them that yes, you can leverage Alpine, all right, with multi-stage to make your image much more smaller. Now, what if I build my image on Alpine? And here should be your answer. Yes, you can take advantage of how small Alpine image is, all right, to use it to use it alongside with multi-stage to make your resulting image much more smaller. All right, so that is a response. I was asked sometimes in an interview, how do I reduce this? How do you reduce the size of an image? I said with multi-stage build. And then I said, okay, so do I have an idea of Alpine? Yeah, I said yes. He said, what's Alpine? Alpine images are images that are lightweight. And I said, okay, if Alpine is lightweight, why do I still need multi-stage? I paused for a while because it is a very logical question and it makes sense. Because Alpine will still give you a smaller image. Multi-stage to give you a smaller image, right? Now, to actually answer that question, you just say yes. To get it to achieve a much more smaller image, it will be best if you combine Alpine with multi-stage build. That's it, guys. All right, great. So that was that. So now let's go into our environment and demonstrate what we are trying to talk about. Okay, so I'll go to this is my base machine. Sorry, my VM. Let me check for my images, Docker images. All right, so I can delete these guys. Docker ps-a. We have a lot. So Docker rmi-f $ Docker images-q. So this should delete everything. So if I say Docker images, I can still have HTTPD. So I can also remove Docker rm-f $ Docker waiting ps-qa. All right. So all the containers are all gone. So Docker images. So now I can finally delete the last image. It's gone. All right. So Docker images, they're all gone, guys. All right. So everything is clean. Now, with sudo -r. Let me see what I have here. Okay. Exit. mkdir. Okay, I have a Docker file. All right, this was the old Docker file. All right. So let me make a directory. Make directory. Let me call it multi-stage. Now change directory into multi-stage. All right. Now I need to create a Docker file. So I'll say vim Docker file. Now I want to show something now. If I say from Ubuntu, co Ubuntu, I will save and quit. I will build this image. I'll say Docker build -t Ubuntu img dot. All right. So I'm going to show something. Now this image has been built. So let's check the image size. This image size from Ubuntu is 77 megabytes. All right. So now I want to increase the size of this image. I want to show something, right? There's a command, there's a tool called file allocate. Take note, guys. F allocate. So F allocate is a utility that is used to create a file of a specific size. I come again. F allocate is a utility. Okay, let me do it from here. So F allocate. This is a utility that is used to create a file of specific size in Linux. For instance, I need to create a file of size 10 MB. I'll use file allocate. How do we do it? How do we do it? Let's see it. So I'll say file allocate -L, the size, let's say 10 MB. Then I will say file 1. Now let's check. I have file 1 created. What's the size? 10 MB. Now let me check it now. Let me check if it's actually 10 MB. File 1. You can see the size is file MB is, I can say LL-H. So I can say this file is actually what? 10 MB. So with file allocate, I can actually what? Create a file of a specific size. All right, great. So now let's now go into our Docker file and use the concept of file allocate. So I'll go into what? The Docker file. So my base image is from what? Ubuntu. So I need to what? Run some commands. Run file allocate -L 10 MB, okay, and the file name I could say finance.csv. All right. So I could also create another. So that's one layer. So another layer will be file allocate -L, let's say 15 MB, audit.csv. Now, can you tell the size of this image? So I have 15 plus 10 is 25. 25 plus Docker images plus 77. If I build this image, this should increase the size of the image by 25 by 752179 105 105 MB. So let's try it and see. So I'll say what? Docker build -t ubun img dot. Okay, unexpected number of arguments. So let's go back to that file. Vim Docker file. So it's not taking it. So this is what I will do. Run again. Another instruction. All right. Save and quit. Let's build. So this guy has been built. Now let's check the size of the image. Docker images. You can see this image has increased because of the different layers, right? A lot of layers that I am adding to the image, to the Docker file. So if I go into the Docker file again, if I add another layer, so let's say at this time now, I want to add 5 megabytes. The file name should be marketing. Marketing. Now let's build. All right. Now let's check Docker images. Before it was 104, right? 104. Now we are getting 105. Whereas because it was 104, now because I've added another layer, it's now 109. So this is how it will keep increasing. To keep increasing. And by Docker's recommendation, right? By Docker's recommendation of Docker best practices, right? Docker said that when you're building your image, you must build your image with multi-stage. All right, multi-stage. Because the idea of Docker is because of its lightweight. Because of its lightweight, so many technologies are absorbing Docker. They are picking up Docker. They are using Docker. Now, if Docker continues to be very heavy, if your images continue to be very heavy, it's going to add another overhead to your environment, right? So, which doesn't make sense. So that's why Docker said for best practices, it is required that you build your image with what? Multi-stage, right? Multi-stage. Now, what does multi-stage say? This method is used to reduce the size of a Docker image. Okay, now this method the multi-stage, this method could also all right, this method is used to retrieve a layer. All right, let me put it like this. How does it work? How does multi-stage works? Right. So this method, this is how it works. It's used to retrieve a layer from a previous layer. Or I would say from a previous build, all right? It's used to retrieve a layer from a previous build. Now let me explain. Now, here is my Docker file. All right. This is from all of these layers are from this base image, Ubuntu. All of these layers, these dependencies, they are from this build. Now, assuming that what you're building is only this last line, this last layer that is important to you. You know, you will have dependencies, you install dependencies, you will do a lot, you will do this, you do that. And everything will now be what? Compiled into maybe the last line. This is an illustration. And it is only this last line that you need. You don't need all of these lines. You don't need this finance.csv, audit.csv. It is assumed that you have built this application and everything has been integrated into marketing.csv. Both finance and audit has been integrated into what? CSV. And it is only this line, this marketing.csv line, that you need. So meaning that every of these things now is garbage. They are just garbage. They are just adding unnecessary space to your image. That's where multi-stage comes in. All right. So now, what this guy says is that the method, how it works is, it works by retrieving a layer from a previous build. So this is what I want to do. Because this layer, let me set line number. Because layer 5 is very important to me. And that's where my entire package is. Right? So I'm going to copy that line. I'm going to retrieve that line into a new image. into a new build within this Docker file. So this is what I will do. I'll say what? I'll create another base image. Now, before I do that, let's try to download Alpine Linux, Docker pull Alpine. Let's look at the size of Alpine. Now, Docker images. Can you see Alpine? You see how small Alpine is? Alpine is just what? 7 MB. 7 MB. So with the concept of what? Of multi-stage. I want to what? I want to use multi-stage alongside with an Alpine image so that it will further reduce the size of my image. Only Alpine cannot do all of this for you. Take note, guys. This is where this guy comes into play. This is where this response come now. Because only Alpine cannot get you that kind of small image. Fine, Alpine is small, is lightweight, but you need to use Alpine alongside with what? Multi-stage. Then it's going to make your image much more smaller. Let's go back. Okay, so let's go back to our Docker file. I just wanted to show us the size of what Alpine looks like, right? So Docker images, Docker Vim Docker file. So now I'm going to be pulling from I'm going to use this next build, right, which is stage. This is the first stage. This is my next stage. In this next stage, I'll be pulling my base image from Alpine. Now, I need to retrieve this layer. Let's set line number. So I need to retrieve this layer that is important to me from this stage into this stage. So what do we do? So there's a syntax, there's an instruction for it. The instruction is copy -- from. Before you do this, you need to label this stage. This first stage, you need to label it. So to label it, you say from Ubuntu as builder. It could be any name, but it is always for best practices, all right? It's nice we use a nice keyword. Builder, app, any name, Toby, any name, but it should define what the stage is doing, all right? It should define what your application is. So just keep it simple. So from Ubuntu as builder. So this is what I'm doing. I'm creating a label that's is like a tag, right? I can call this stage from anywhere, right? With the use of what? This label. From Ubuntu as what? As builder. Now, I'm the next stage now. I need to call this important line from this build. From this build, right? So I'll say copy from equal to builder. That's the label name. The label name of this stage is what? Is builder. You need to set a label name. The label name is what? Builder. So copy from -- from equal to the label name space. I'm copying this important part. All right? This important part. So I'll now say what? Marketing. Marketing.csv into maybe /opt. So I need to copy this file, all right, from this stage into what? /opt. Now, when I will build this image, Docker will only build the last from instruction. And it's going to ignore the previous from instruction. So it's going to build upon what? This last from instruction. That's what Docker will do. So if I escape, I do WQ. I do a Docker build. Docker build - this Ubuntu img. Let me give it a tag version 1 dot. Now let's check now. Docker images. What do we see? Version 1. You can see this image has been reduced from 109 towards just 12 MB. 12 MB because let's see our Docker file again. What's the size of marketing? The size of marketing.csv is what? Is 5 MB. And the size of Alpine is what? Is 7 MB. 7 plus 5 is 12 MB. This is the idea behind reducing the size of an image. I can further reduce the size of this image. All right. Now, at this level, I would say I want to run another instruction. Run file allocate -L. Let me see departments dot txt. This is 2 megabytes. All right, 2 megabytes. Okay. Now, if I build this image, let's build this image based on version 1. Now, Docker images plus 2, it will be 14 MB, right? It's now 14 MB. Now, let's go back to that Docker file. I want just what? Just only this layer. So I will create another from instruction. So I want to create a label. So I want to add label as build. That's a label for that Alpine stage. Now I can come down here now. I'll say from Alpine. Then I'll say copy -- from build. All right. What am I copying? I'm copying departments dpt.txt into where? Into /mnt. Escape. Save and quit. So the moment I save and quit, Docker is going to build this last instruction. It will ignore all of these instructions. Now say what? Docker build -t Ubuntu img version 2 dot. It has been built. Now let's check Docker images. Docker images. What are we seeing? The size of the image is reducing. I'm successfully reducing it to its barest minimum. So with the concept of multi-stage, we can actually reduce multi-stage and Alpine. We can actually reduce the size of an image, right? So now, that being said, let's now build a real-time image, right? Let's build a real-time image based on Java and Maven. Now, let me create a real Docker file. Let me say let's say Vim. All right. Before I do that, let's go to Google. Let me show something. Let's download the simple Java Maven application. All right. GitHub. Simple Java Maven. Now look at this application. I want to build this application, right? So this is what I will do. I'll copy this URL. I'll go to my base machine. All right. I'll do a git clone. I'll clone it. I have cloned it. All right. I will use the name because it's too long. I will move simple to app Maven or Maven app. I have reduced it. All right. Great. Now I need to create a Docker file. One second, guys, please. 1 second. Okay. So now let's start creating the Docker file. So call this dev. All right. Vim dev. So in this Docker file, I want to pick my initial base image from Maven. So I'll say from Maven Alpine. Let's check official image of for Maven. Maven, right? Official Docker image. Then I'll need Alpine. Where is that search? Maven tags. Search for tag. Alpine. Is Maven Eclipse 3.9 3.9.5. Let me take oldest 3 points. This with Java with JDK. I don't want with JDK. I don't want with JDK. Okay, 3.39, 3.3.9 dash Alpine. All right, let me try this. Let me do this. Copy this guy. Come over here and paste it. So I'm going to remove this excess. So my base image is from Maven column 3.3.9 dash Alpine. Let's check something now. Let's check. So if I build this image now, if I say Docker build dash T is let me call it multi dash img, right? Then Docker file is df dot. So let's see the size of that image after building. Now, if I say Docker images, you see with me that this image. So this is the size. So this is the size of this Alpine, Maven Alpine is 116 megabytes. See how large it is. All right, great. So let's go back to our Docker file. So yeah, that's okay. Now calm down. So here now I need to copy my my Maven app that I downloaded from GitHub. So I'll say copy. So I need to move it. Copy app-maven into somewhere inside of the container /app. So this is what's happening. So I'm copying this guy from my base machine into what? My container, my image. All right. So at the end of the day, what will happen is if this this location, this part is not there. So copy is going to create this part inside of the image. All right. So that's what's going to happen. Okay, great. So after this phase now, I want another layer. The next layer will be my work directory, work dir. My work dir is /app. So meaning that I've copied this guy into this guy. So when you write work dir simply means it's like you're doing a change directory. That is what this guy means. This instruction means it's like you're changing directory, right? Which is your working directory, right? Great. So change directory. Then I'm going to run Maven build command, Maven goal. It's called a Maven goal. So I'm going to run Maven package. So this Maven package is going to build this image. It's going to build this application. There's an application here that's going to build it, all right, and create it as a jar file. It's going to wrap it, all right, create it as build it as a jar file. So that is a jar file that I need. The jar file is very important to us, right? So it means that our entire code is inside of the jar file, right? But before then, let's run this image and see what happens. So I'll escape, I'll save and quit. So I'll do a Docker build, the same multi-img. I'll hit enter. So it's going to run this goal, Maven package. So that's why it's running now. So if it is successful, what is it saying? Final memory is build failure. Okay, fail to execute goal. Maven enforcer 3.4.1. Okay. Now it's failing because of the version of what's it called? The version of Maven we are using. Now it's saying that it detected Maven version 3.3.9. It's not in the allowed range of 3.8.6. So it also failed with this again. Failed with message. Detected GTK version 1.8. Meanwhile, this application is designed to run with Java 8. So let me just take us through this Maven application for a while. Now, there's a pom.xml file that Maven uses to build its application, to package its application. When you're writing a Java application, the Java developer always writes a pom.xml file, right? And this pom.xml file, it is a file that defines all the dependencies, how the application should work, right? The version of the Maven you should use to build the application, and the version of the Java you should use to build the application. So from all indication, which means from this error, it is showing that we are not actually using the required Maven version. It's saying that this version that we are using from that base image is out of range from what is defined in the pom.xml file. Similarly, this Maven comes with a Java version 1.8, right? And it's not in the recommended version of what? Java 11. Now, if I open this file now, pom.xml, let's open it and see. Let's go to, should be somewhere. They have defined what Maven version you should use. Maven Java plugin 3 points. What was this? Okay, they are enforcing this version 3.4.1, right? Now, this is the required version. Require Maven version 3.8.6. It means that you must look for a Maven version of 3.8.6 for this process to work, right? So anything below 3.8.6 will not work. It has to be from 3.8.6 and above, all right? Then the required Java version is what? Is Java version 11. Now, let's try and see if you can find, let's go back to our Docker file. If we can find what 3.8.6, I'm replacing 0.6 Alpine. Think if, let me see if I can search for this image. Copy this image. Right click, copy. Let me save this guy. I'll say what Docker search. I can see this particular thing. It's not there. Let's remove Alpine. I could actually see 3.8.6. 3.8.6 with Java 14. This with Java 8. I can't see Alpine. 3.8.6. 3.8.6. Let's look at the official documentation. Let me search for that guy. We can't get this. We can't get it. Let me see. We can't even get 3.8.6. Oh, older. Let me see A to Z. Oh, newer. No deal. Z to A to Z. What is this now? Older. What am I seeing? 3.2 newer. 3.9, 3 points. Okay, let's try and let's just use it. Let me see something. Let's use it. Let's come over here. Let's check. Cat Docker file. All right. Now let me try to build it one more time. Build. Let's see if the error that we have. All right. So it can't find that image. The base image cannot be found. What we could see is OpenJDK 8. All right. OpenJDK 8 only. All right. Let's try and use something else. Let's use 3.9. Let's do a search again. Docker search. Maven 3.9. I could see 3.9.1 Eclipse. Dimitri. 3.9.4 Amazon Corretto. This is with Java 17. All right. 3.9.4. Let's search. I can't get 3.8. Okay, 3.8 points. What was there? 3.8.6. Let's check. 6. All right. So 3.8.6. We are getting, can we get Alpine out of this? Can we get Alpine? Can't get Alpine. Can't get Alpine. Can't get Alpine. So we can get OpenJDK 18 Slim. Okay, let's check OpenJDK. OpenJDK 11. Can we get 11? Yes. So we can get 11 Slim. So this is 11 Slim is, you see the size, 231. And ordinary 11 is 322. Okay. Bam, 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 bam. Now let me look without open that Java. Amazon Corretto. This with Java 8. This with Java 8. I need ordinary 3.8.6. Because okay. Okay, yeah, it is 3.8.6, maybe 3.8.6. So let's use that guy. So let me go inside here, back to my Docker file. Sorry, back to my Docker file, and 3.8.6. Escape, save and quit. Now let's build. Docker build. So it's downloading from 3.8.6. All right. So it's very big image. So let's look at our Maven goal, Maven package. Let's see if it works. All right, guys. So you can see the build was successful. All right. The build was successful. And our building jar was copied into this location. Apt, targets. This is our entire application. The whole of these things is reduced into this small file. The whole of this application, this app Maven, the whole of these things that are here is reduced into this small file. All right. So, guy, one thing I will also tell us is, you are never alone. You are never alone. If you are working in an organization and you have been told please article please, this is a Java application, dockerize this application. Dockerize what? This application. Now, the developer will always tell you what to do, because inside of this form.xml file, the developer has defined his dependencies. He has defined all his dependencies. He has defined all his constraints. Now, the developer said that for this application to work perfectly, this application requires what? Java version what? 3.8.6. Sorry, Maven version 3.8.6. And this Maven version comes alongside with what? Java 11. All right. And it requires what? Java 11. So if you had defined Java 8 here, you still know how to build it. All right. So this is the process, guys. All right. This is the process. Okay. So you are never alone. Your developer will always tell you what to do. All you need to know is know how to go about it from your own side, from your DevOps perspective. Know how to build your stuff. All right. Great. So now that we've built this image, let's copy this guy. Copy this guy. Because that is the result from this stage. That's the result we got from this stage. The result that we got from this stage is that guy. All right. So I'm going to, let me paste it somewhere here so I will use it. Because this is what we need. This is what we need to copy from this stage. You can see, let me show something. If I say Docker images, what was the size of that image? Multi, where are you? Guys, can you see the size? 547. What are we doing? It's almost getting to 1 GB. 500 and what? 47 megabytes. It's too large. So I don't need all of these things. I don't need all of these things. All these things you're seeing, plus even this Maven sheet. I don't need it. The only thing I just need, this Maven should just use what? This Maven goal, Maven package, to package the application, the Java application, into what? A .jar file. Package it. And this is what we got from that build stage. So this is the build jar. I just need to copy this jar. That's the only thing I need. All right, that's the only thing. Okay, then I need to create another stage. So let's go back to our Docker file. So in this our Docker file, I'll say from OpenJDK 11. Let me go and search for OpenJDK. Java, sorry, OpenJDK. All right, I need version 11 official. So I'll look for tag. I'll look for Alpine. I need 11. Version 11. OpenJDK 11. OpenJDK 11. OpenJDK. I got C Alpine. I will not see like this. OpenJDK 11 Alpine. Thank you. Alpine. So what am I seeing? I'm seeing this is Java 7. Java 7. This is Java 7, Java 8. 11U. Let me check for 11U. 11U. Can't see 11U. I can get 7U. I need 11U. I'm coming, guys. Let's search here now. Open JDK 11 Alpine. JDK 11. JDK 11. Let's check this. This is sponsored. It's not actually official. Sponsored OSS. Always be careful, guys. It's not official. Let me look for something official. Open JDK 11. These are not official. Okay, let me check something. Open JDK. No. These are tags. Overview. JDK 11A. Deal. Okay, open JDK 11. So this alone. All right, let me try this. All right, let me try that. So I'll say I needed just Alpine. Open JDK 11. Let me try if I can see this thing Alpine. Let me try it like this. Now, so we are copying this jar file from this stage. All right. So I'll now say what? Copy dash from, we have to set a label. So go up from this guy as what? Builder. So I'm copying from what? From builder. From builder, I'm copying this guy into somewhere, into let's say app.jar. Simple, app.jar. It means that all of this stage has been copied. All of this stage that has been built into this small jar, I am copying it from this stage into what? This other stage and into this file, right? That's all, guys. And I'm using what? OpenJDK 11 Alpine. Let me see if that guy is available. Let's build it. So I'll say Docker build. This should be version 1, not latest, version 1. Let's see if that image the image is not available. OpenJDK Alpine is not available. All right, let me just use only OpenJDK. But before then, let's try to pull that OpenJDK 11. Docker pull OpenJDK column 11. Let's just see something. Let's look the official size. Now let's do Docker images. Where's the guy? JDK. Wow. Wow. Almost. This guy is large. It's even larger than what we are trying to set up. So we need to look for that Alpine. Let me look for OpenJDK 8. Let me look for OpenJDK 8 Alpine. OpenJDK 8 Alpine. Let's check. Official image. I'll be forced to use something else soon. This is also not official. But Okay, open column JDK. Let me see if I can get something like this. Let's come here. Let me search. Docker search. Open JDK column 11 dash JDK dash Alpine. No D. Let me try that 8 again. 8. Or 8 yakba. Let's try something. I don't try some before now. No D. 11 Alpine. No, because seriously, we need to reduce that size of that image. We need to reduce the size of that image. It's too big. It's too big. Correcto. Let me look for okay. Okay, can we see 11 here? Can see 11. But can't see 11 Alpine. All right, so I can see 11 Alpine here. Oh, great. So 11 Alpine. Okay, let me see this. Let me see this. Okay. Go back. 11 Alpine. So let me copy. Oh, yeah. Copy that tag. So I think should be available now. So go into your file. So this should be okay. 11 Alpine 3.16. Okay, let's see something now. Let's build. Let's build. Let's build. Let me call it V1. It's not available. Wait. Oh, sorry. Amazon Corretto. It has to be Amazon Corretto. So it comes like this. Copy. All right. So it comes like that. So if I do Docker search, Amazon Corretto, column like this. So this is based on Java 11. Why now? Docker pull Amazon Corretto. One six column. Okay, so this guy is available. So if I do a Docker images, So Amazon Corretto is based on Java 11. So the size is manageable, 273, right? Assets 654 and 547, right? So now let's now use that image. This image the way it is. Copy this guy. Copy, go into your Docker file, and we paste it. This is based on Java 11. So escape, save and quit. Then let's build now. So Docker build version 1. Everything was successful. Let's check our image size. So you can see our image size V1 has been reduced from what? 547 towards 273. 200 what? 73. All right. So it means that look at now. It's just it's only taking even the image, the size of the Amazon Corretto Alpine. So it means that this guy itself is very infinitesimal, very small. The size is 0.0 something bytes. It's not even adding up. It's not adding up to the complete image size. So great. So we have the last level, which is we need to execute we need to create a container out of this image. So I'll say what CMD. So CMD, I'll use Java dash jar, all right? Jar. Then my application is on what? App.jar. That's all, guys. That's all. Escape, save and quit. So now let's build it. So Docker build version 1. So it was successful. So Docker images 273. So let's create a container out of this guy. So I say what? Docker run -d -- name multi-con based on the image multi-img version v1, right? So this container has been created. Let's check Docker PS. Let's see it's exiting. So Docker PS -a. So this is the container name, multi-cons. Let's check why it's exiting. So I'll say Docker logs multi-con. Unknown operand, okay, jar. So this is what we'll do. Go back to the image. Go back to your Docker file. It's an unknown operand. So let me remove this open brace. Now, let's rebuild it. Docker build. Let's rerun it. Docker rm multi-con. Let's rerun it. Now, Docker PS -a is exiting. Now let's check Docker logs, Docker log multi-con. So you can see the application is now running. So this application is designed just to display hello world. Where's that guy now? So if I go to source, main app.java, right? So you can see hello world, just hello world application, just to display hello world, private static final message, hello world. So that is what this application is designed to do. So it's just display the message, then exit. So you can see we have successfully built our image and run it as a container based on what? Based on multi-stage build. So this is the idea, this is the concept, and how a multi-stage is built in Docker. At this juncture, guys, is there any query? Is there any query? All right, so since there's no query, I will end this recording so that I wouldn't want to mix it up. So I can start another one, which is volume management, Docker volume management. So let me end this. Stop recording. Stop recording.